Hi, Assalamualaikum and good day. Today you are going to learn about the application of integration that is on volume of solid of revolutions. Following is the objective of today's lesson. Hopefully, by the end of this session, you should be able to evaluate the volume of a solid of revolutions by these and washer methods. A solid of revolution is a solid figure obtained by rotating a plane curve around straight lines, which is referred to the axis of revolutions that lies on the same plane. Following are some examples on solid of revolution in the shape of cylinder, cone, sphere, and vase. Basically, volume is defined as the area of a cross-section multiplied with the height, or in the short form, V equal to A times H. Volume of solid of revolution can be calculated using integration. Three common methods for finding the volume are this method, washer method, and the cylindrical shell method. Generally, this method is used to determine the volume for the full solid object. Meanwhile, both washer and cylindrical shell methods are used to determine the volume for the hollow object, or in other words, solid with a hole. This method calculates the volume of the solid of revolution by summing the volumes of the thin vertical circular disc. Consider a rectangle. When we spin this rectangle around a line, it creates a circular shape. This rectangle creates more than just one circle because it has a thickness or width which look like a disc. The volume of this single disc is defined by V equal to the area of base multiplied with the width, which is equal to pi r squared dx. Thus, to find the volume of a solid of revolution which contains multiples of disc about the x-axis, we need to integrate pi r squared with respect to x over the given interval. Consequently, to find the volume of a solid of revolution about the y-axis, we need to integrate pi r squared with respect to y over the given interval CD. Generally, the volume of a solid of revolution can be obtained using the following formula of the this method. Take note that if the axis of rotation is at the horizontal axis, then the volume is obtained by the integration with respect to x. Consequently, if the axis of rotation is at the vertical axis, then the volume is obtained by the integration with respect to y. Basically, r, which refers to the radius of the disc, represents the height of the rectangle, and it is equal to the top function minus with the bottom function if the rotation is at the horizontal axis, or r is equal to the right function minus with the left function if the rotation is at the vertical axis. Refer to example 1. Find the volume of the solid obtained by rotating about the x-axis, the region bounded between y equal to x, y equal to 0, x equal to 0, and x equal to 4. To solve, first identify the top function and the bottom function for the solid of revolution. As the graph is rotated about the x-axis, the top function is y equal to x and the bottom function is y equal to 0. Thus, r is equal to x minus 0, which is equal to x. As the rotation is at the horizontal axis, by applying this method, the volume is equal to the integration of pi r squared with respect to x from 0 to 4. Integrate x squared, the answer is x cubed over 3. Substitute both limits of integration into the answer and simplify. You will obtain 64 over 3 pi units cubed as the answer. Now refer to example 2. Find the volume of the solid obtained when the area of the region is bounded by y equal to square root x, y equal to 0, and y equal to 2 is revolved at A, the y-axis, and B at the line x equal to -3. For A, as the graph is rotated about the y-axis, the right function is x equal to y squared and the left function is x equal to 0. Thus, r is equal to the right function minus with the left function, which is equal to y squared minus 0 equal to y squared. As the rotation is at the vertical axis, by applying this method, the volume is equal to the integration of pi r squared with respect to y from 0 to 2. Integrate y to the power of 4 is y to the power of 5 over 5. Substitute both limits of integration into the answer and simplify. You will obtain 32 over 5 pi units cubed as the final answer. For B, as the graph is rotated about the line x equal to -3, the right function is x equal to y squared and the left function is x equal to -3. Thus, r is equal to y squared minus 3, which is equal to y squared plus 3. As the rotation is at the vertical axis, by applying this method, the volume is equal to the integration of pi r squared with respect to y from 0 to 2. Integrate y to the power of 4 is y to the power of 5 over 5. Integrate 6y squared is 6y to the power of 3 over 3, and integrate 9 is 9y. Substitute both limits of integration into the answer and simplify. You will obtain 202 over 5 pi units cubed as the final answer. Next, let's proceed with the second method of finding the volume, which is known as washer method. This method is an extension of this method for finding the volume of a solid of revolution that has a hole. Assume that we have a rectangle that is perpendicular to the axis of revolution, but this rectangle does not touch the axis. In other words, there is a hole in between. By revolving the rectangle about the axis of revolution, the volume is obtained by minus the outer radius, which is denoted by the capital R, with the inner radius denoted by small r. That is, V equal to the integration of pi multiplied with big R squared minus small r squared with respect to x over the interval AB. Thus, to find the volume of a solid of revolution about the x-axis or y-axis, we need to integrate the volume with respect to x and y respectively as given by the following formula. Take note that when the rotation is at the horizontal axis, the capital R, which refers to the outer radius, is equal to the top function minus with the axis of rotation, and the small r, which refers to the inner radius, is equal to the bottom function minus with the axis of rotation. Consequently, when the rotation is at the vertical axis, the capital R is equal to the right function minus with the axis of rotation, and the small r is equal to the left function minus with the axis of rotation. Refer to example 3. Find the volume of the solid formed by revolving the region bounded by the graph about the x-axis. Here, the graph is defined by y equal to x squared and y equal to square root x. To solve, first we need to identify the outer radius and the inner radius for the solid of revolution. As the graph is rotated about the x-axis, we need to integrate with respect to x, meaning the function must be in terms of x. Here, the outer radius is equal to square root x minus 0, and the inner radius is equal to x squared minus 0. Therefore, square root x with the square minus x squared with the square is equal to x minus x to the power of 4. So, this is the function that you need to integrate. By applying Washer method, integrate pi multiply with x minus x to the power of 4 with respect to x from 0 to 1. Integrate x is x squared over 2, and integrate x to the power of 4 is x to the power of 5 over 5. Substitute both limits of integration into the answer and simplify. You will obtain 3 over 10 pi units cubed as the final answer. Proceed with example 4. Find the volume of the solid generated by revolving the shaded region about the y-axis. As the graph is rotated about the y-axis, we need to integrate with respect to y, meaning the function must be in terms of y. Here, the outer radius is equal to square root y minus 0, and the inner radius is equal to y over 2 minus 0. Therefore, square root y with the square minus with y over 2 with the square is equal to y minus y squared over 4. By applying Washer method, integrate pi multiply with y minus y squared over 4 with respect to y from 0 to 4. Integrate y is y squared over 2, and integrate y squared over 4 is y to the power of 3 over 12. Substitute both limits of integration into the answer and simplify. You will obtain 8 over 3 pi units cubed as the final answer. Refer to example 5. You need to find the volume of the solid generated when the shaded region is revolved about the line y equal to -1. As the graph is rotated about the line y equal to -1, which refers to the horizontal axis, we need to integrate with respect to x. Therefore, the function must be in terms of x. Here, the outer radius is equal to x to the power of 1 over 2 minus with -1. And the inner radius is equal to x minus with -1. Then minus the outer radius with the square with the inner radius with the square and simplify. You will obtain 2x to the power of 1 over 2 minus x squared minus x. Integrate this function with respect to x and substitute both limits of integration into the answer, then simplify, you will obtain 1 over 2 pi units cubed as the final answer. In order to check your understanding on today's lesson, please do the following exercise. In the next lesson, you will learn about the cylindrical shell method in evaluating volume of solid of revolution. So,